Okay, students, let us now understand the concept of LCM in a very simple way, because this idea is very important in partial fractions. We will first take a numerical example and then connect it to algebra. Suppose we have three fractions: a divided by 5, b divided by 5 square, and c divided by 7. Before adding these fractions, all denominators must be equal. So we first find the LCM of 5, 5 square, and 7. Now observe carefully. We have 5 and 5 square. Both have the same base, which is 5. Whenever the base is same and powers are different, we keep only the highest power. So between 5 and 5 square, we keep 5 square. Then we also have 7, which is different, so we include it. Therefore, the LCM becomes 5 square into 7. Now let me give you one important note. Whenever the same base appears with powers up to the highest power, say power 4, then while writing partial fractions, we start from power 1 and continue up to the highest power. That means we write base power 1, base square, base cube, base power 4. So if the denominator contains x plus 1 power 4, then the partial fractions will be one term with x plus 1, one term with x plus 1 whole square, one term with x plus 1 whole cube, and one term with x plus 1 power 4. This is the standard pattern. Now let me give you one side note. Suppose the denominators are three completely different numbers: 5, 9, and 13. Here none of them are related. No number contains the other. So in such a case, the LCM is simply 5 into 9 into 13. That means when denominators are all different, we multiply them directly. But when same base appears with different powers, we keep only the highest power. This is the key difference. Now coming back to our example. Once the LCM is found, compare each denominator with the LCM and ask, what is missing? Then multiply the numerator by those missing values. Take the first fraction, a divided by 5. The LCM is 5 square into 7. So one more 5 and one 7 are missing. So numerator becomes a into 5 into 7. Take the second fraction, b divided by 5 square. Only 7 is missing. So numerator becomes b into 7. Take the third fraction, c divided by 7. 5 square is missing. So numerator becomes c into 5 square. Now all denominators become same. So final answer is a into 5 into 7 plus b into 7 plus c into 5 square whole divided by 5 square into 7. Now let us connect this same idea to algebra. Suppose we have a divided by x plus 1 plus b divided by x plus 1 whole square plus c divided by x plus 3. Now look at the denominators: x plus 1, x plus 1 whole square, and x plus 3. Since x plus 1 whole square already contains x plus 1, we keep only the highest power. So the LCM becomes x plus 1 whole square into x plus 3. Now compare each denominator with the LCM. For a divided by x plus 1, one more x plus 1 and one x plus 3 are missing. So numerator becomes a into x plus 1 into x plus 3. For b divided by x plus 1 whole square, only x plus 3 is missing. So numerator becomes b into x plus 3. For c divided by x plus 3, x plus 1 whole square is missing. So numerator becomes c into x plus 1 whole square. So students, remember these rules. If denominators are different numbers, multiply them. If same base repeats with different powers, keep only the highest power. If partial fractions are to be written, start from power 1 and continue up to the highest power, then multiply the numerator by whatever is missing. That is the complete idea of LCM in partial fractions.